Hello students, myself Shivi Jain. Today I'll be teaching you a topic which is the first most chapter of your class 11th as well as your class 12th mathematics, which is sets, relation and functions. So let's begin with it. So what are we going to mostly study in this chapter? Firstly, what are sets and its different types, relations and its types, functions and how do we define a function. Moving on. So firstly study what are sets and its types. So see, set is what? Sets is nothing but a collection of well-defined objects which are distinct from each other. Now let's study its types one by one. So null set or empty set, a set which contains no elements. Correct. It is represented by this phi. A set which contains no element is called a null set or an empty set. Signature set, a set which contains only one element. Yes, study these two. Correct. Finite set, a set which contains finite number of elements. We call it a finite set. Infinite set, a set which contains infinite number of elements. Then we call it an infinite set. Give an example, R. R meaning what? R means real numbers. Real numbers are infinite. Hence we can say R is an example of infinite set. Moving on, equal sets. I'll give an example for this. Let me take two sets like A, in which I take the elements like 1 and 3. Take one more set B. In this I'll take the sets like 3 and 1. So are these two sets equal? Yes, they are, because A contains 1 and 3 and similarly B also contains 1 and 3. Order does not matter. You will say, ma'am, but in B it is written 3 1 and A it is 1 3. No students, it does not matter the order. What matters is you should have the same elements 1 3 3 1 3 same. So hence these are what? Equal sets. Now, telling about equivalent sets. See, it is different from equal sets. Equivalent sets, it does not matter what elements you have in a set. It matters that you should have same number of elements. Like over here, for example, A has 1 and 3. B, if I make it like, let me make this 4. Okay, so now are these two sets A and B equal? You will say no, obviously not, because 1 3 and 3 4, obviously they aren't equal. But you will say A and B are equivalent sets. Why so? Because A also contains two elements and B also contains two elements. Hence they are what? They are equivalent sets. Now talking about subsets. See, subsets is nothing but when every element of A is related to B, then we call it a subset. Okay, every element of A is related to B, then we call it a subset and it is represented by this symbol. Okay, over here it is necessary that A has to be equal to B. Okay, then only call it a subset. Proper subset is also very similar to it, but it has one difference point from subset. Is nothing but A is a proper subset of B. We represent it like this. A is a proper subset of B if every element of A is present in B, but not necessary कि A has to be equal to B. Then we call it a proper subset. Okay, it's not necessary A has to be equal to B, but A should be a subset of B. Then only we call it a proper subset. Okay. Chalo, subsets are over, proper subsets are also over. Universal set is represented by a letter U. This means what? A set which consists of all the elements which are to be involved in a discussion. Then we call it a universal set. Power set. See, I'll tell you. Let me take an example. Let A be a set. It will obviously have subsets. So the collection of all those subsets is nothing but what? Power set. Okay, power set. Set A which has subsets and the collection of all those subsets is nothing but what? Power set. Now moving to the last set, disjoint sets. What are disjoint sets though? Disjoint sets meaning if I'm making two sets, say example A and B. I'll give an example also. Let A be let's say 6 and 11. Okay, and let me take B which consists of 1 1 1 and 60 6. So are these two sets disjoint sets? Yes. Why so? Because neither of the element which is present in A, they are not present in B. Hence A and B are what? Disjoint sets. Now, if I ask you a question for this example which I have given previously, are these two sets disjoint sets? No. Why so? Because 3 is a common element in both. But for disjoint sets, A and B should have none of the elements common in them. A intersection B should always be equal to phi. Hence, this is not a disjoint set, but this is a disjoint set. Okay, so I hope you understood all these sets. Now moving on to relations. Like how we are studying for sets, there are like various types. Similarly for relations also we have lots of types. I have considered the few most basic, most important ones. So we'll study them one by one. Reflexive meaning what? See, reflexive is one key if every element of a set is related to itself, meaning an element is making relation with itself only. Then we call it a reflexive. Like for example, which I've given here, let R is what 156, but A is 1 1 5 5 6 6. Every element is making a relation with itself. Every element is making a relation with itself. Hence, it is what reflexive. Now moving to symmetric. Symmetric is what? See, if I take two sets, yeah, if I'm taking two elements, let's say A comma B, which belongs to R. So if B comma A also belongs to that set R, then we can say कि this is a symmetric relation. Like the example which I have given here, let R is 1 comma 5 comma 6. So I've defined this set A. So 1 comma 5, okay, it belongs to this set. 5 comma 1 also belongs to this set. This means what? It is a symmetric relation. Understood? So moving on to the third one, that is transitive. See, I'll give an example for this one. Take three elements A, B and C. If A is equal to B, okay, if A is equal to B and B is equals to C, if if A is equal to C, then we say it is a transitive. But if A is not equal to C, but if A is not equal to C, then we cannot call it a transitive. For transitive, A has to be equal to B, B has to be equal to C. That are the two most important conditions. But if A is also equal to C, then only we can say it is a transitive relation. Now talking to the last one, equivalence is nothing but what? If you have a combination of all these three relations, then we call it the equivalence relation. Meaning if a set which is reflexive also, which is symmetric also, which is transitive also, then we call these all sets in one is nothing but what? Equivalence set. Now moving on to the last topic, that are functions. So see, functions is what? If to every value of a variable, like say x, which belongs to set A and corresponds to only one and only one finite value of the quantity y in my set B. Okay, how do we represent it? Let's say a function from A to B, like A to B, y is equals to f of x. Let's say how we represent it pictorially. X is the input which I'm putting in a function f, and I get my output as f of x is equals to y. You can consider this like f is nothing but a machine. You're putting some input in it and then you get your output, right? Oh, your y. This is my set y and this is my x. So y is called image of x, whereas x is called the pre-image of y. Do keep this in mind. I've taken an example here, y is equals to 3x. So by keeping different values of x, I'll get different values of y, and that value is going to be 1 and only 1, and that is going to be finite. See, if I've kept my x value as 1, I get what? 3 ones are 3. X has 2, 3 twos are 6. If I x 3, 3 threes are 9. Hence, it is what? It is a function. Okay. So, I hope your students understood this lecture well. So, keep learning. Thanks for watching. Thank you. All the best.